The title of this webinar is Modeling of Active Components and Devices, Integrating SimphoSOFT Active Modeling into VirtualLab. Here is the outline. First, I will talk about SimphoSOFT features and benefits, then discuss VirtualLab, which is made by LightTrans, and talk about its features and benefits. Then I will show how to integrate SimphoSOFT into VirtualLab, giving 3 examples. Example 1 is an optical limiter, which is an organic multiphoton absorber. Example 2 is a neodymium YAG amplifier. Example 3 is a ring-resonator. At the end, I will summarize what I've just talked about. Note that we are looking for your feedback. Please send us your requirements for optical simulations that can utilize the combination of SimphoSOFT and LightTrans. Send by email to support@symphotech.com or to service@lighttrans.com. Here are some SimphoSOFT features and benefits. SimphoSOFT is an optical simulation program that models rate equations and light transport through materials. It handles both linear and nonlinear light-material interactions. SimphoSOFT can handle an unlimited number of material energy levels and an unlimited number of optical transitions, as shown by the example figure on the right. Transitions include multiphoton absorption, stimulated emission, energy transfer, and so on. SimphoSOFT can handle both pulsed or CW beams. It can show you energy level populations found by using rate equations. SimphoSOFT can handle 2 or more beams at the same time and can be used for optimization of material properties. Expanding on the SimphoSOFT features and benefits, I show some examples of material energy levels and optical transitions. On the bottom left is an energy level diagram with 5 energy levels for an organic molecule called AF455. This example will be shown in the webinar. Another example shown in the webinar is neodymium YAG laser crystal or amplifier material. It's shown here with a simplified model with 4 energy levels. SimphoSOFT can be used, though, with materials having many more energy levels and transitions. Example is shown here on the right. In this case, there are 2 ion types in the sample, ytterbium and erbium. There are 10 energy levels total, 2 for ytterbium and 8 for erbium, and close to 30 optical transitions, including energy transfer up conversion, and up conversion, in addition to normal absorption and relaxation phenomena. VirtualLab has a different set of features and benefits. VirtualLab has great flexibility in source, propagation, and detector modeling. You can model optical components such as lenses, mirrors, gratings, and devices, for example lasers, amplifiers, microscopes, and so on. This is shown schematically in the picture on the right, where you see lenses, freeform lenses, gratings, phase plates, and so forth. The modeling of optical components and devices is something that SimphoSOFT cannot do. VirtualLab can do full vectorial ray tracing, and it can do field tracing using numerous methods, including geometric optics field tracing, baraxial field tracing or beam propagation method, Gaussian field tracing, unified field tracing, and VirtualLab has customization. For example, you can integrate VirtualLab with SimphoSOFT so that you can run SimphoSOFT from VirtualLab. Integration of SimphoSOFT into VirtualLab allows users to combine and benefit from the features of both software packages. If you want to do this integration, you will need the following: SimphoSOFT 3.2.2 or later, the SimphoSOFT link to run SimphoSOFT from VirtualLab, example SimphoSOFT and example VirtualLab project files, and VirtualLab Advanced 5.11 or later. To get the software from SimphoSOFT, you can ask for a 30-day free trial, and we will give you access to the web page where you can download SimphoSOFT 3.2.2. You can download the link to VirtualLab, And you can download example project files both in VirtualLab and SimphoSOFT formats. Next, we're going to go to the three examples. Example 1 is an optical limiter, which is an organic multiphoton absorber. In the upper left, we show the VirtualLab light path setup, which includes a Gaussian input beam, an absorbing component, and an output. For these first two examples, we're going to keep the VirtualLab light path quite simple. We're not going to put in any lenses, mirrors, or so on. Basically, what we want to show is how to run SimphoSOFT from VirtualLab. In the upper right is the supporting SimphoSOFT project, which includes a source and a material sample. Below that is the energy level diagram for the sample. It has 5 energy levels, 3 singlet states and 2 triplet states. Then in the bottom left is a typical VirtualLab output. Now we're going to go to the VirtualLab itself and look at the program. So here is VirtualLab. We're going to open this project. I'm going to open, it's the MPA project. Takes a few seconds for it to open. You'll see the light path here, the Gaussian input beam, the absorber, and the output. The input beam is set up to have very high power for multiphoton absorption. If you look at the power of the beam, we've set it to 102 megawatts, which is very high, but it's the type of thing you need for multiphoton absorption and to demonstrate optical limiting. Now I'm going to click on the absorbing component. You can see that it's 7 millimeters thick. Go to field tracing and you can see a script. Let me click on source code editor. There's a scripting language that allows us to run SimphoSOFT from VirtualLab. We will provide you with a scripting language. The only thing you need to do is change the location of the correct files on your computer. As I'm highlighting here, the file directory is on my computer, but you'll have to change that to where the directory location is on your computer once you get the programs and try to run them. Before we run the project in VirtualLab, we first have to go to SimphoSOFT and generate the supporting documents that VirtualLab needs to run the program. Right now I have SimphoSOFT opened. First, I should note that if you're using SimphoSOFT for the first time, you can go to File, New. There are template files here that you can load and run without having to generate the files yourself. There's a whole list of different applications here. For one thing, there is a import-export in VirtualLab. And there are the 3 files that I'm working with today are already loaded here, and you can generate a new project with each of those files. For example, you can click on this one for multiphoton absorption, give it a name at the top and hit create. That will load the file into SimphoSOFT. I'm not going to do that today because I already have the files in my computer. I'm going to go to File, Open, going to click on the directory MPA Gauss. Here's the SimphoSOFT project file with an extension SSFT. Click on it and click on Open. My project opens. Here I have a source and a sample. I set up its properties so it also has 102 megawatts. Right now this says microwatts. I'm going to change that to megawatts. And you'll see there it shows up as 102 megawatts. So I set the source to be the same 102 megawatts as in VirtualLab. The sample, if I right click on the sample, you'll notice it's 7 millimeters thick. I can click on MCAD, and here's my energy level diagram for the multiphoton absorber. These are the 3 singlet states, 2 triplet states. If I right click on this transition, you'll see it's a 2-photon absorption. The other 2 absorptions, if I right click on them, you'll see they're single photon absorptions. The blue lines and orange lines are relaxation lines. I want to note here that you can look at the rate equations for these 5 energy levels. Go to diagram equations. Down at the bottom you'll see 5 equations 0 through 4, which correspond to the 5 energy levels 0 through 4. One of the great advantages of SimphoSOFT is it's very easy to modify this energy level diagram. For example, I can add a new energy level by clicking on the energy level icon. Default parameters, put it where I want it. It's now a new energy level here. I go into properties and I need to give it some arbitrary energy. I'm going to make it 10. So the energy level is set up. Now I want to set up absorption and relaxation transitions on this diagram. For absorption, I click on the absorption icon, click clean parameters, put it where I want it, go into properties. Right now it's a single photon absorption. I need to put in a value for its cross-section. A typical cross-section for single photon absorption is 1 e to the minus 17 square centimeters. So I put that in. So my absorption's done. Now I want to add relaxation. I click on the relaxation icon. Again, click clean parameters, put it where I want it. I need to right click, go to properties, and I need to set a relaxation time. I'm going to set it to 1 picosecond. So that is done. So now I've modified my diagram. I've added a new energy level, a new absorption, a new relaxation. If I go down to the bottom on the rate equations, you'll see now there's a new rate equation labeled 5 for this new energy level 5. So that's how easy it is to change my energy level diagram. I should also note that there are other types of transitions here. Here's energy transfer, up conversion, cross relaxation, which you can use for other types of ions such as rare earth ions. For now I'm going to remove these transitions and energy level that I've just added. Go back to my 5-level diagram. Now I need to generate the files that VirtualLab will need to run the program with this 5-level model. I do that by clicking File and Export to VirtualLab. And I'm done with what I need here. I'm going to close this program now. If I go to the directory where my SimphoSOFT project was, this is the SimphoSOFT project with extension SSFT, you notice there are now 2 new files, 2 XML files, this one and this one. These 2 XML files will be used by VirtualLab to run SimphoSOFT from VirtualLab. So now I'm going to run the program. Takes just a few seconds. Now it's done. I'm going to look at the output field. We've asked it to look at the field halfway through the sample, and here's my input field. I'm going to put all 3 of these in data view. The input field, if I click on it, go to view data, you'll see that was the 102 megawatts. That was my input field into the multiphoton absorber. If I look at halfway through the sample, click on it and view it, you'll see the power has dropped to 48 megawatts. If I look at the output of the field, the power has dropped to 34 megawatts. So the sample itself has done some optical limiting. It's limited about 70% of the input power. The input power was 102 megawatts. Halfway through the sample it dropped, and at the output it was down to 34 megawatts. So this is not a perfect optical limiter, but it demonstrates optical limiting. So now I'm going to close this program. We've finished with this example. Now I'm going to example 2, which is a neodymium YAG amplifier. This is going to be an end-pumped amplifier, and we're going to look at a single pass. On the upper left is the VirtualLab light pass setup. Here you'll see a seed beam, an amplifier section, and an output. Note that VirtualLab light path can only have one light source. In this case it's going to be the seed source. But for the amplifier you really need two light sources, a seed and a pump. That can be done in SimphoSOFT. So the pump beam is going to be included in the SimphoSOFT amplifier section of this project. So the right here shows the supporting SimphoSOFT project. There are two light sources, a seed beam and a pump beam, both going through the sample in end-fired fashion. The energy level diagram is a 4-level model for neodymium YAG. This is sort of the simplest model for neodymium YAG. And again, in SimphoSOFT you can make it a lot more complicated if you want. Then in the bottom left is showing some amplified output in VirtualLab. So now we'll go to the programs themselves. We go to VirtualLab, and we're going to open up the new project, this time for the amplifier. And this is a project. I'm going to open it. Again, this is the VirtualLab light path, where we can have a seed beam, but we cannot have the pump beam in VirtualLab light path. So we include the pump beam in the amplifier section. If I double click on the seed beam and show it, go over to the right and look at its power. We're going to set it up as about 2 microwatts for the seed beam. Now I'm going to close that. If I double click on the amplifier, you'll see that the thickness of the amplifying section is 5 millimeters. And if I go to field tracing, again there's going to be a source code, which is a scripting language that allows SimphoSOFT to run from VirtualLab. I expand this. Again, we will provide you with this scripting language. You don't need to worry about it. When you run a program, you need to change this directory location to the directory on your computer where the XML project files are located. Okay, so now we're going to go over to SimphoSOFT and look at the project in SimphoSOFT. I'm going to open this project. It's going to be this one. Open this project file with the extension SSFT. Open. So here's my project in SimphoSOFT. I'm going to click on ECAD, make this smaller so you can see what's going on here. You'll see there are two sources. This is my seed beam, this is my pump beam. Both are going to go through the sample. Seed beam, I've set it for 2 microwatts, just as in the VirtualLab project. Pump beam, going to set it now, let's change this to watts. It's now set for 5,000 watts. So this is a fairly strong pump beam, 5,000 watts. It's going to go through the sample and pump the sample. Note that in SimphoSOFT we can have these 2 beams, or we can have more than 2 beams if we need it. And this is something that's not possible in VirtualLab. So the pump beam are going to be in this SimphoSOFT project and be transferred into the XML file which VirtualLab is going to read. The energy level diagram, neodymium YAG, again it's a 4-level model, the simplified model. And again, if you're working on high power neodymium YAG, you may have to add more energy levels to accurately model what's going on. So I have this project now in SimphoSOFT and I want to export it to VirtualLab. It's done. So now I can close SimphoSOFT. Again, if I go to projects, my project directory where the SSFT SimphoSOFT project was located, you now see again there are 2 XML files that were generated by SimphoSOFT. And these are the files that this script language is going to read in VirtualLab to run the project in VirtualLab. Now I'm ready to run the project in VirtualLab. I mentioned before there's a seed beam here, but I also have to tell VirtualLab what the pump beam looks like. So the user has to set up the pump beam in VirtualLab also, just the magnitude of the optical power. Click on this, open. I have my pump beam here. If I look at its power, it's 5 kilowatts, the 5,000 watts. So I need this open in VirtualLab to run the project. Click on the light path, click on Go. And it asks me for what the pump field is. It's listed here since I have it open in VirtualLab. I click on it, click OK. And now the project runs. Now this project is going to take about 2 minutes. Let me mention one thing while we're waiting for the project to run. In the VirtualLab light path, I could only have one laser beam, which is a seed beam. We had to add the second beam through the scripting language in SST amplifier. Notice also that in this project we did not add any more complications such as lenses or mirrors and so on that VirtualLab can do. Again, this is just to make it simple and to show you how to run SimphoSOFT from VirtualLab. The project is still running. I'm going to skip some of this and just show you the end result when the project finishes. Okay, the simulation is finishing up. And is now complete. I still have my pump beam over here to the right. One of the outputs is the reduced field. Reduced field is what the pump looks like after it's gone through the crystal. Then I have an amplified field, and let's look at the seed field. Okay, I'm going to set all these into data view. Go back and look at the seed field. Again, that was set up as 2 microwatts. Now let's go look at the amplified field after it's gone through the amplifier. It's now 106 milliwatts. So it's a very large amplification. I've gone from 2 microwatts to 106 milliwatts. And notice the shape of the field too. The amplified field is narrower than the original seed field because most of the amplification is occurring in the center of the beam. So that's the amplified field. Now I'll go back to the pump. The pump started out as 5 kilowatts, 5,000 watts. And the reduced field is what it looks like after it's gone through the crystal amplifier. And here the power at the output of the amplifier is about 895 watts. So the pump has lost power from going from 5,000 down to about 895 watts. So this demonstrates an amplifier. We've used SimphoSOFT to set up the seed and pump beams, and we exported that to an XML file. The VirtualLab read the XML files and was able to run the program, showing you what happens to both the seed beam and the pump beam as it's going through the amplifier. So this completes this project. I'm going to close all the windows. So now I'm going to example 3, which is a ring resonator. I'm going to show you the simulation of one round trip through the ring resonator. The ring resonator is shown on the left is in a 3D diagram. It has 3 mirrors. You start out on a plane, send the beam to the first mirror, then it goes to the sample, to the second mirror, third mirror, back to the original plane. In the VirtualLab light path, you see a seed beam, and it goes to mirror 1, and it goes to the amplifier section, then mirror 2, mirror 3, and to the screen. On the upper right here you see the supporting SimphoSOFT project. Again, it's an amplifier project with 2 sources, a seed beam and a pump beam. Below that is the 4-level energy level diagram for neodymium YAG. Again, we're going to use the simple 4-level model for neodymium YAG. And to its left is the VirtualLab output. So now we'll go to the project in VirtualLab. Open the script project, it's ring resonator project. It's this one. I'm going to open it. Here you see the light path. Again, the seed beam, mirror 1, amplifier, mirror 2, mirror 3, and output. So this is a more complicated type of system that you can set up in VirtualLab. Here we have mirrors, but you can also add lenses, gratings, and a lot of other different types of components. And that type of thing is not possible in SimphoSOFT. Also in VirtualLab you can look at a 3D view of this. Clicked on 3D, and you'll see the image here in 3D, and you can rotate it if you want. There's a plane to start with. The beam goes to a mirror through the sample, which is not especially clear here. It goes to the second mirror, third mirror, and back to the original plane. Here's the light path, again seed, mirror, amplifier, mirror 2, mirror 3, and back to the beginning. First let me double click on the seed beam. Again, it's going to be a 2 microwatt seed beam. And I'll close this. Double click on the amplifier. Go to field tracing. Source code editor, and as on the other 2 projects, here's the scripting language which will let SimphoSOFT run from VirtualLab. Again, we'll supply you with the scripting language, and again you'll need to change the location where the XML files are located. Okay, now we'll go to SimphoSOFT. And we're going to look at the supporting project in SimphoSOFT. Go to File, Open. It's going to be this file, or this directory, this file. Going to make the experimental CAD smaller so you can look at it. So SimphoSOFT has the seed beam, 2 microwatts, has the pump beam. Let's change this to watts. It's 500 watts. So in this example we're going to use a lot smaller pump beam, 500 watts instead of 5,000 watts. So this is what the project looks like in SimphoSOFT. Again, in SimphoSOFT we are not able to put in mirrors, lenses, and that type of components which are possible in VirtualLab. Look at the MCAD, and here's my energy level diagram. To export this energy level diagram and two beams to VirtualLab, again I go to File and Export to VirtualLab. And that is done, so now I can close SimphoSOFT. As before, if I go to my project directory for this project, you'll see the two new XML files that were generated by SimphoSOFT. Again, in the light path, I have a seed beam. I need to tell VirtualLab separately what the pump beam looks like, so that had to be set up. I have to open a pump beam. So it's open in the project. If I look at this pump beam, it's 500 watts, which I mentioned before. Now I'm going to run the project. Click on the light path, click on Go. Again, it asks me what the pump beam is. I click on that, click OK, and the project is running. This project will run for approximately 1 minute. To save time, I'm going to skip part of the run and go to the end. Project is now finishing up. Okay, let's look at what we have now. We have amplified field. For the pump beam, we have the pump and we have the reduced field. For the amplified field, we have the seed beam and the final amplified field. I'm going to look at all those in data view. Let's go back to the seed beam. That started out at about 2 microwatts. Go to the amplified field. It's about 4.6 microwatts. So in this case, we only amplified a little over a factor of 2. That's because we're using a relatively weak pump beam of 500 watts. Also, the sample itself happened to be thinner. It was 2 millimeters instead of 5 millimeters for the amplifying crystal. Going to the pump beam, it started out at 500 watts, and the reduced beam after it's gone to the sample has dropped to about 79.9, about 80 watts. So the pump dropped from 500 down to 80. The seed beam had amplified a little over a factor of 2. So that's a third example, and I'm going to close this, close my windows. So now I'm done with the third example. So now I have finished the 3 examples, and I'll go back to the PowerPoint presentation. First, I'll summarize SimphoSOFT and VirtualLab advantages. With SimphoSOFT, you have an easy-to-use graphical user interface where you can set up a very complex energy level diagram with an unlimited number of energy levels and unlimited number of transitions. SimphoSOFT allows both linear and nonlinear light material interactions, such as 2-photon absorption, energy transfer, and so on. And you allow multiple beams, 2 or more beams, which can be used for amplifiers or other applications. VirtualLab has a different set of advantages. VirtualLab is very flexible in terms of source, propagation, and detector modeling. You can set up a lot of different optical components and devices that are not possible in SimphoSOFT. The schematic diagram is shown on the right, where you see a light path that can contain lenses, freeform lenses, gratings, faceplates, and so on. Example applications where you can use SimphoSOFT and LightTrans together include lasers, amplifiers, other rare earth applications other than lasers and amplifiers, optical limiters, life science applications such as two-photon microscopy, flow cytometry, fluorescence imaging systems, cancer diagnostics and treatment. If you wish to get a 30-day free evaluation copy of SimphoSOFT, just go to our website, click on free trial, and sign up for the 30-day evaluation. We will send you a full version of the software in 2 or 3 days. Also, if you need a free evaluation copy of LightTrans, go to the lighttrans.com website. For additional information, you can go to SimphoTech.com website or lighttrans.com website. If you have questions, you can email me at bsandk@simphotech.com or to the addresses below. SimphoTech runs webinars from time to time. You can go to simphotech.com/webinars to get a listing of new webinars. We are looking for your feedback to design better software products. Send us your requirements for optical simulations that can utilize the combination of SimphoSOFT and LightTrans. Send by email to support@simphotech.com or to service@lighttrans.com. Thank you very much for your attention, and this is the end of the webinar.